Our next speaker is a Debian developer. He's interested in upstream in package kit developments, and he made some contribution to a desktop environment like KDE or GNOME. Today he will speak about Listaller, which is a way to distribute third-party applications based on package kit. And let's applause Matthias.
Okay, is the phone, can everyone hear me? Oh, okay. Is it better now? Yeah, of course. I want to introduce you to Listaller, which is a simple and secure way to distribute third-party applications, as it was said before. Or, in other words, it is another solution to create cross-distribution packages. So first of all, you might all know this one. So I created with some others a cross-distribution packaging system, but we already have packaging systems. We have one in each distribution, and we also have some who are aiming for a similar goal. So first of all, I should better answer the question, why do we need a cross-distro installation system at all? So first, the main reason is that people want new software which is not available in their distributions. They have a stable base distribution and want the latest and greatest stuff to be installed and to try it out. There are rolling release distributions, but they don't fit everyone's use cases, because there are still many people who want a stable operating system which does not exchange the kernel or other components while it is run. Also, there could be backports, but the distributor resources are usually limited, and less people are interested in backporting stuff to a stable distribution. So there's a great lack of manpower, and it also has some other issues when you try to backport something. There are, of course, third-party repositories, which are called, in the Ubuntu world, PPAs, personal package archives, but those are insecure and they can potentially break your system. For example, if the PPA packager introduces new packages, which then get replaced by other packages from the distributor which are slightly different during an upgrade, your whole upgrade will fail and you will have a broken system, which is very difficult to recover. At least for users who don't have a technical background. Also, every packaging solution has the option to run scripts with root permission. So if you install an application from a malicious source, you really don't know what this thing is doing unless you looked into it, but usually users don't do that before they install software, because they want to see the software running and don't bother with the installation process and with reviewing a package. Also, last but not least, PPAs are distribution specific. There are many PPAs for new software which are only available for Ubuntu, but Fedora and Debian need different sources, so it doesn't. It's lots of duplication. The OpenSUSE build service solves that partly, but you still have to write lots of different spec files to package everything. Also, if you have want to ship your software as a binary installer, you again have the problem that this will execute code during installation, which often happens with root permission. So it's not something we should be wanting to do. So why is Listaller better in that regard? First of all, it was built with system integration in mind. That means that the user should never notice that Listaller is used when installing applications. Listaller applications should, when they are installed, integrate seamlessly with every existing application in the system, so they should not look like foreign objects to the system, well, to the user. Also, software updates should be retrieved automatically using the same user interfaces as the system uses itself, because sometimes if you are installing third-party stuff on Linux, you have like another updater application, and this is really not user-friendly to do that, to have multiple sources to install software or to update your system. Of course, it should be cross-distro and cross-deso compatible, and it should be simple, which means that Listaller is not able to install basic system components, like for example an init system or a toolkit or something which has reverse dependencies on itself, because Listaller was built solely for applications or so-called leaf packages, and everything else which really requires integration by the distributor should be handled by the distributor and not by the upstream project which is creating the Listaller packages. Of course, it should be secure, which means that every Listaller package is usually signed. Signatures are checked against the hints database to see if it is a malicious signature or if the signature is known to be malicious. And every application installed with Listaller will be sandboxed, which will soon be possible using the KDBus stack, which allows pushing large chunks of data into a sandbox using portals. But that's a different technology, which is pending implementation. Listaller also provides developer tools, which means that developers get helpers to make the application run on multiple distributions, and packaging is really simple for them, which means they only need to write a small file usually, and then they can get started with packaging. So after telling you all of that, you can imagine that the Listaller consists of multiple tools which can be divided into end-user applications, which are, for example, as an application which sets up the sandbox and runs the application, an application to manage a database of trusted keys, lots of developer tools which handle different things, from tracing dependencies to making the application relocatable, which means that you can place it anywhere on the file system and it will still find its dependent data files. And also, of course, a generator for Listaller packages, and a tool to generate update sources and repositories to allow the creation, a theory of Listaller packages, of Listaller repositories which target the whole Linux market. So you set up a repository with Listaller packages, and every Linux distribution can embed it and can use it. So how does this work? Listaller is actually a PackageKit plugin, which means that it runs inside PackageKit. PackageKit, for those of you who don't know what it is a tool which is a debug service which takes requests from client, be it software centers, package managers, or update viewers, and then performs an action on the native distribution interface, which means that PackageKit has plugins which get called by the debug daemon running as root, and then they get asked to perform the actual action on the native distribution package management interface. So Listaller now hooks into this by creating some kind of meta backend between the native backend and the PackageKit abstraction. So if PackageKit receives a request to install a Listaller package, and Listaller notices that inside PackageKit, it will perform the installation of the new package and send all information about this new package via the PackageKit's debug interface back to the clients. So for the clients, it doesn't matter if they install a Listaller package or a native distribution package, because for them it just doesn't matter at all. If there is a native package, of course, Listaller will let it through and let the backend perform the appropriate action. Listaller can also query the backend instance directly, which means that Listaller has the opportunity to talk directly to the native distribution package manager and resolve dependencies and install missing dependencies if necessary. Speaking about dependencies, in order to make Listaller work on multiple distributions and to have dependencies, which is something we want at least for basic dependencies like GTK, because if you link the whole toolkit statically and the distributor pushes an update which fixes a critical security hole, and you have an application running on your system which has, for example, the toolkit statically linked, you won't get that security fix into production, because the statically linked application will still use that old library. So it is a good idea to have at least some base level of dependencies. And in order to resolve dependencies, dependencies using the native distribution package manager on multiple distributions, Listaller relies on so-called components, which define the interfaces an upstream project provides, which binaries, which libraries, and in which versions it does that. Ideally, it also ships a symbols file, so we can check if the ABI compatibility is given. Then Listaller will use this component file to actually find the right dependency in the distribution database. So it, to some extent, depends on upstream projects to write component files. But there are some workarounds, but because this is a lightning talk, I can't go into detail. So let's walk through the process and package bloatpad. After reading the GNOME developer documentation, our developer decides that this is a good idea to create a package for that. In order to do that, we need to do a few things. First of all, write an app data file. App data is part of the upstream effort to create cross-distributional software standards. And if you ship an app data file, your application will be represented better in any software center because we will have more metadata to take into account. So an app data file is just a small bit of XML which defines the project summary, a description, the name, a desktop file, homepage, etc., and some other stuff. Listaller will take this file to present the application to the user and say, yes, you're installing this thing right now, and later it will also inject that data into the upstream database. So every upstream-aware software center is able to display the Listaller application just like any other application which was installed from a native distribution source. Then you need to write a few rules in how to compile your application. This can be done using AppCompile here because AppCompile is a small wrapper which will detect your build system and build the stuff. It works with a few build systems so far, but yeah, you can also add all instructions on how to build your applications manually there. Then you need a file listing. Listaller does not use any absolute file path. Instead, it uses relative file paths where you can place your application in. During installation, Listaller will then decide, depending on the distribution's policy, where to put the application files, and therefore the distributor in the end controls how everything is installed. You also need to write a so-called PK options file, which just defines how the package creation process will be done and which version of the packaging standard you will want to use. Then you just need to generate your package, which will automatically run depscan, which is a small tool to detect all dependencies your application has, and then match them to components using the component interface definition I've shown you before. In this case, we, for example, detect GTK3, glib, xorg, an icon theme, and gstreamer because this thing is called bloatpad. Then it will just generate the package structure and sign the package, and run Lilith, which is a small tool to validate pieces of the upstream work in order to get a high quality package and to tell upstream, hey, you're doing this wrong, maybe fix it next time. So by doing that, we can address one of the concerns of distributors that upstream projects might create crappy packages, because Listaller won't allow doing that, and if there are some minor tweaks which can be done, it will warn the upstream developer about that. So in the end, you have a package. This can then be installed by the user using the native package management tools, or using tools which are dedicated for installing Listaller packages. But the long-term plans are to get rid of these. There is an extension to PackageKit which will be done in a few weeks, which might render the additional interface completely obsolete. Listaller will then search for native packages which declare that they support the missing components and install them. If Listaller is unable to satisfy dependencies using the native package manager, it can also fall back to get dependencies from other sources if it is configured to be allowed to do that, because the system's administrator might not want that Listaller tries to satisfy the dependency from potentially untrusted sources like third-party repositories in order to satisfy the application's dependencies. then in the end, the user wants to run bloatpad, so he executes run app bloatpad, which is set up the sandbox, and do some other crazy stuff, so the application is able to find its dependencies. Yeah, and then this thing right now only supports older desktop file standard. Sooner it will also support the new dbus activated applications, which is the new way to store applications, at least in future. Developers can also create update repositories, which is also pretty simple and straightforward in order to generate an App Store-like feature. And yeah, in our example, our user decided to remove bloatpad, so he just opens Apple on KDE, the tool he is used to use to work with packages, finds bloatpad there, and hits the uninstall button, and it's just gone without any problems. Yeah, and that's it.
We have the time for a quick question, maybe? I see him.
So, if I understand you correctly, you ship binaries, but how do you solve the problem of installing in an arbitrary directory? Because you said you don't specify which directory it has to be installed, but then you have a problem with libraries and they don't know where to find the libraries and things like that.
Well, there are two approaches to that in Listaller. One is patch elf, which will change the elf header of the binary, which is really ugly. So the preferred way right now is that the run app application sets the library path for the new libraries, and therefore makes the application find its libraries if they are living in a different directory.
Yeah. I'd be interested to talk to you about that.
Hello, one quick question. I don't know if you already said it, but can you use the native package management system like apt-get to install Listaller packages?
No, you can't, because then the native package management system would have to link against listaller in order to be able to do the same as PackageKit does right now. It is in theory, it's possible, but I don't think the upstreams of native package managers want to do that right now, at least.
A last question? Okay, Matthias will give another talk on this topic tomorrow morning at this same building. This will call Upstream and Installers, and it's at 10 o'clock.